In the world of space exploration, SpaceX's Starship stands as a bold new chapter, one that redefines what's possible for humanity's journey beyond Earth. It's an audacious leap toward full reusability, a vision that could transform the economics and frequency of spaceflight forever. Unlike any rocket before it, Starship is engineered for rapid, complete reusability, not just incremental improvements, but a total rethinking of how rockets are built, flown, and reused. Every previous rocket, even the groundbreaking Falcon 9, has treated major components as disposable, with boosters often lost to the ocean or left behind after a single use. Starship aims to end that era, ushering in a new standard where rockets are as reusable as airplanes. The system is made up of 2 stages, each designed to return safely and be flown again and again. The first stage is the Super Heavy booster, powered by 33 advanced Raptor engines, providing the immense thrust needed to escape Earth's gravity. Above it sits the Starship upper stage, equipped with 6 more Raptor engines designed for both orbital flight and deep space missions. Together they form the tallest, most powerful launch vehicle ever constructed, dwarfing anything that has come before. The ultimate goal is airline-like operations for space, where rockets are flown, recovered, and relaunched in days, not months, dramatically increasing launch cadence. This breakthrough could slash launch costs, making space accessible to far more people, organizations, and even entire nations than ever before. Starship isn't just a bigger rocket, it's a vehicle for making humanity multi-planetary, opening the door to new worlds and new possibilities. Only with full, rapid reusability can we dream of building outposts on the Moon and Mars, and truly begin to settle the solar system. Starship's revolutionary design is the first real step toward making that extraordinary future possible, forging a path for generations to come. When SpaceX first unveiled its plan to recover the massive Super Heavy booster, the world responded with a mix of skepticism and awe. Many experts and engineers dismissed the idea as science fiction, doubting that such a feat could ever be achieved. The concept was bold: catch a falling rocket with enormous mechanical arms, rather than letting it land on traditional legs. These so-called chopsticks, part of the towering Mechazilla structure, would reach out and grab the returning booster mid-air, eliminating the need for heavy, complex landing gear and saving precious weight for future missions. After stage separation, the booster performs a dramatic flip, carefully slows its descent, and navigates with pinpoint accuracy back to the launch site, hovering as the giant arms prepare to catch it in mid-air. Critics questioned the precision required and the risks involved, but SpaceX's engineers pressed forward, undeterred. Through countless simulations, hardware tests, and late nights, they refined the system, determined to make the impossible possible. Then, on October 13, 2024, during Starship's 5th integrated test flight, the world watched as the unthinkable became reality. The Super Heavy booster returned from the edge of space, engines blazing and the chopsticks closed in, catching it with breathtaking accuracy and control. It was a watershed moment for spaceflight, a vivid demonstration that even the wildest engineering dreams can be realized with vision, persistence, and innovation. SpaceX didn't stop there. They repeated the feat, proving to the world that this was no one-off stunt, but a new standard for rocket recovery. Audiences around the globe watched in amazement as the definition of rocket recovery was rewritten before their eyes, inspiring a new generation of engineers and dreamers. Today, Starship's booster catch stands as a powerful symbol of what's possible when relentless ambition meets world-class engineering, forever changing the future of space exploration. Starship's journey has been a masterclass in learning from failure. SpaceX's rapid iterative testing means pushing hardware to the limit, and sometimes beyond. Early test flights ended in explosions, but each failure brought crucial data and improvements. The first full-stack launch in April 2023 exploded minutes after liftoff. The second flight achieved hot staging, but both stages were lost. By March 2024, Starship reached space and demonstrated key maneuvers before being lost on re-entry. The breakthrough came in June 2024. Both booster and ship completed controlled splashdowns, proving the system's core design. Yet, setbacks continued. Explosions, leaks, and mid-flight breakups in 2025 reminded everyone how hard this is. Each failure, though dramatic, is a step toward reliability. The path to routine, reusable spaceflight is paved with hard-won lessons. Catching the booster was a monumental engineering challenge, but returning Starship safely from orbit is an even greater test of ingenuity and precision. As Starship plunges back to Earth, it must survive re-entry at a blistering 17,500 miles per hour, enduring searing heat, blinding plasma, and immense aerodynamic forces that threaten to tear it apart. SpaceX's innovative solution is the dramatic belly flop maneuver, using the ship's broad underside and 4 articulated flaps to slow down, steer, and maintain stability as it slices through the thickening atmosphere. Moments before landing, Starship must execute a rapid flip to vertical, reignite its engines, and attempt a soft, controlled touchdown. An acrobatic feat made even more daring by the absence of traditional landing legs. The first major milestone is to land Starship on a reinforced offshore platform, floating at sea and designed to absorb the immense forces of landing. Ultimately, the boldest goal is to catch Starship mid-air with the giant mechanical arms of Mechazilla right at the launch tower. Controlled splashdowns in the ocean have already proven that the concept works, demonstrating Starship's ability to survive the return journey. But achieving pinpoint landings on a platform and perfect catches by the tower remains some of the most difficult technical challenges SpaceX faces. Mastering this entire sequence is absolutely key to making Starship fully and rapidly reusable, revolutionizing space travel. Each test flight, each landing attempt brings SpaceX one step closer to making orbital return not just possible, but routine and reliable. The journey to tame the orbital beast is far from over, but with every trial, SpaceX pushes the boundaries of what's possible in space exploration. Starship's development is driven by one goal: make spaceflight radically cheaper. For decades, launching to orbit cost thousands per kilogram, an economic barrier for all but the biggest players. SpaceX aims to cut launch costs by over 99%, targeting around $1 million per TOS per flight. The secret isn't magic, it's reusability. Hardware is flown, recovered, and reflown, spreading costs over hundreds of launches. Propellant and operations become the main expenses, not the rocket itself. This shift could democratize space, enabling universities, startups, and even individuals to reach orbit. Ambitious missions, giant telescopes, lunar bases, Mars cities become possible. Starship is the key to Elon Musk's vision: a self-sustaining city on Mars, millions of tons delivered affordably. The economics of Starship could transform humanity's future in space. NASA recognized Starship's potential, awarding SpaceX the contract for Artemis lunar landings. The mission relies on Starship's unique abilities, refueling in orbit, then landing astronauts on the moon. This requires multiple launches, in-orbit docking, and massive propellant transfers, none of which have been demonstrated yet. Test failures and technical hurdles in 2025 raised concerns about delays. In response, NASA opened the lunar lander contract to other providers, increasing pressure on SpaceX. Elon Musk's team doubled down, seeking faster, simpler solutions to keep America ahead in the new lunar race. The partnership is now a high-stakes mix of collaboration and competition. SpaceX must deliver, not just for Mars but for America's return to the moon. Starship is more than a rocket. It's a bet on humanity's future in space. If SpaceX succeeds, it could make all other launch systems obsolete and open orbit to everyone. Starship's massive payload and refueling capability could enable permanent bases on the moon and Mars. The scale shifts from short-term missions to long-term settlement and industry. The journey is far from over. Setbacks are inevitable, but each test brings progress. Mastering re-entry, booster catch, and in-orbit refueling are the next big hurdles. Starship is a testament to bold vision and relentless iteration. The outcome will shape humanity's destiny. Will we stay earthbound or become a multi-planetary species? SpaceX is forging the key to a future among the stars.